Hello everyone, let's start with the problem split array by prime indices. So this was asked in biweekly contest 161 today itself. So it says you are given an integer array nums they've given and split nums into two arrays A and B using the following rules. Okay, they've given nums, you will have to split the array into two uh, into two arrays basically. Each element at prime indices in nums must go into A. Okay, all other elements must go into array B. So return the absolute difference between sum of the two arrays, sum of A, sum of B. A prime number is natural number. I think you guys know what is prime number, so don't worry, I'll be explaining on the board. An integer array has sum, an empty array has sum of 0. Okay, so let me take you to the board, what they're saying. So first example is 2, 3, 4. So they have given an array which is 2, 3, 4. So if you consider its index is 0, here we have index 1 and here we have index 2. So we guys know what is prime numbers. Prime numbers are numbers which are divisible by 1 in itself. So if you consider 2, it is divisible by 2 and it is divisible by 1, and any other number it cannot divide. So by division what we mean is that if you take let's say any number x, if you want to divide that number by y, then the remainder has to be 0. So prime number, I think you guys know what it is. So we'll have to split this array into A and B array such that, let's say I'll consider A as a prime number, non-prime number index. So this is non-prime. 0 is not a prime number because prime number starts from 2, 2, 3, 5, 7, 11, 13, something this way. So 0 is not a prime number, so I'll put in here. 1 is not a prime number, I'll put in here. 2 is a prime number, so I'll put in B vector, B array. So now if you take sum, this is basically 5, and if you take this, this is 4. So if you take the difference between them, that is 1. So which is given here. 1 is the answer. Now let's try to understand this one. Minus 1570. Minus 1570. So if you consider indices, these are the indices. Now let's take array A. 0 is not a prime number, so it will go here. 1 is not a prime number, it will go here. 2 is a prime number, it will go in B. 3 is a prime number, it will go in here. So if you add up, this is 4, and if you add up, this is 7, and difference between this is minus 3, but absolute value is 3. So this will have to return it. So I think it's an easy problem only. I'll be solving without creating A and B vector. I'll be using just two variables. So let me show you what I mean is that. So first I'll take int A. This will be storing non-prime numbers, and int B, this will be storing prime indices values. So I'll take n, which is basically the size of the vector. So I'll iterate through a loop. I'll iterate through this nums array through a loop. So I will check if is prime. What I'm checking, index will have to check it. So I am passing that is prime. If it is a prime index, I'll be writing this function, don't worry. So if it is a prime index, then in B I'll be storing its value, so nums of I. If it is not a prime index, then in A I'll be storing, I just wrote on the board. So yeah, at the end we'll have to return absolute value of A minus B. So now let's write this function is prime. So I think you guys know how to write, how to find prime number using sieve over Association. If you guys don't know, you can go to YouTube or Google and search it what is sieve over Association, how to find a basically prime number. So we'll have to check here if n the index, because array index starts from 0. So if it is less than 2, then it is not a prime number, right? 0 is not a prime number, 1 is not a prime number. So in that case we'll have to return false. Else we have to use sieve of Eratosthenes. So I'll take I, which starts from 2, and I star I less than equals to n. So this is basically square root of n. We will be checking number from 2 to square root of n, not more than that, because sieve of Eratosthenes theorem says this thing. So you guys can Google it out. So now I'll be increasing I one by one. Here I'll be checking if this n, whatever we have, modulo I, if it is divisible, which means remainder is 0. So in that case it is not a prime number, because prime number means the number which are divisible by itself and 1. Else if in this loop the I value from 2 to square root of n does not divide the n, so in that case it is a prime number, which means it is divisible by itself and 1. So yeah, this is it. We'll try to run the code. So it is running fine. Let's try to submit the code. Acha, we have long, so we are using integer, that is the reason. So let's try to define ll as long, because long random will take time. I mean, it is very large number, that's why. So now let's try to use this test case and run it out. Yeah, it is running fine. Let's try to submit the code. Yeah, it got accepted. So yeah, in this way you can solve this problem. But if you try to analyze the time complexity of this, so this loop is taking O of n, but we are using calling again is prime. This is prime will go to till square root of n. So its time complexity is n into square root of n, and its space complexity is O of 1, because only two variables we are using. We are not using two split arrays A and B. Instead of that, we are on the go. We are just adding the values present at the index, nums index, at the go we are adding in A and B respectively. So yeah, thank you guys for watching the video.